In this video, we'll go through the rules of naming amides, or amides. And so those are another class of organic compounds that contain the carbonyl group. So they have that carbon-oxygen double bond. The carbon of the carbonyl is bonded to a carbon, but it also has a nitrogen attached. That nitrogen could have a hydrogen attached along with a carbon, or it can be two carbons, or it can be two hydrogen atoms attached. And so there are different ways in which you can see the amide drawn or written, but the key thing is that you have the nitrogen bonded to the carbon of a carbonyl. So once you identify that bond, you know that you're dealing with an amide. So if we go through the rules of naming amides, as with other carbonyl containing molecules, we need to identify the longest continuous chain of carbon atoms that includes the carbon of the carbonyl. So we can't skip over nitrogen atoms and say that this molecule has 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms, because you're counting carbon, and nitrogen, of course, is not a carbon. So I only have 2 to the left of the nitrogen, but let's say I had 10 to the left of the nitrogen. It wouldn't include the carbon of the carbonyl. So we don't even need to focus on that side of the molecule initially. What I would recommend when you are trying to identify your parent chain, locate the carbonyl. From there, count to get the longest continuous chain of carbon atoms. So starting at the carbon of the carbonyl, that would represent 1, 2, 3, 4, 5, 6 carbon atoms. And so my longest continuous chain of carbon that includes the carbonyl would be hexane, those 6 carbon atoms. However, we have these 6 carbon atoms, but we also have the presence of a functional group. So as you've seen with the other molecules, the ending of the name changes. So we drop the E and we replace it with amide. That accounts for the amide functional group. So instead of hexane, it becomes hexanamide. From there, we have to identify any substituents. So I don't have any substituents, any branches sticking out on the parent chain side of the molecule, but I can see this substituent attached to the nitrogen. That one substituent contains 2 carbon atoms, so I know that it represents an ethyl group. So if you had to indicate or tell someone where that ethyl group was located, what would you tell them? Most would say that the ethyl was branching or attached to that N, to the nitrogen. So just as you would tell someone that it's attached to that nitrogen, that's the same thing that you would do when naming it. We would indicate that it's attached to the nitrogen. Because remember, we only number our parent chain. And this blue part represents the parent chain side of the molecule. This orange part represents the substituent that is attached to that nitrogen. So I don't number that. I can't number the nitrogen. It's not a carbon. It's not part of my parent chain. So you have to identify your substituents, and then you want to indicate where they are located. So I've done that by indicating N. That's the only substituent that I have, so from there I can put it all together. When I put the name of this together, so you still want your substituents first, I still need to indicate where that substituent is located. It was attached to the nitrogen, so the name of this molecule becomes N-ethyl hexanamide. 6 carbon atoms in a continuous chain that contains the amide functional group with an ethyl attached to the nitrogen. But let's say that you were given the name of the molecule, and instead you were asked to draw the structure. So let's say you were asked to draw the structure of N-ethyl, N-methyl, butanamide. So as we've already seen, the name can tell you pretty much all you need to know about the molecule, at least structural wise. And so seeing that word amide, we know that we're dealing with the amide functional group. So we know we're going to have a carbon bonded to an oxygen, double bonded to an oxygen to make the carbonyl. Attached to that carbon, we'll have a nitrogen. We don't know, just by looking at the word amide, whether or not that nitrogen has 2 carbons, 1 carbon, and a hydrogen, or simply 2 hydrogen. But we can look at the rest of the molecule to figure it out. The but portion lets us know we have 4 carbon atoms in a continuous chain. It also lets us know that this functional group is attached to the chain of 4 continuous carbon atoms. So that's my parent side of the molecule. So I can go ahead and start with that if I wanted to. But I'm going to go ahead and finish analyzing this name. So I have N-methyl. The methyl, of course, lets me know one carbon atom, but the N tells me where this one carbon atom is attached. The ethyl lets me know two carbon atoms. So each of these represent one substituent, but they contain a different number of carbon atoms. They're both attached to the nitrogen. So from there, I can go ahead and draw my structure. Butanamide, so I know I need 4 carbon atoms, so I'm going to go ahead and draw my 4. So remember, as soon as I put this marker down, I'm on carbon 1, 2, 3, 4. Again, just because I'm counting 1, 2, 3, 4, doesn't mean that I have to number it that way. Once I put in my functional group, then that will dictate which way I number. So if I wanted to put my functional group at this very last carbon, then it would become carbon 1. If I wanted to put it at the first carbon, it would become carbon 1. I typically draw mine from left to right, but you can draw from right to left, and that is not a problem. So I would, since I have my 4 carbon atoms, make this last carbon the carbon of my carbonyl. So now that means that technically this carbon now becomes carbon 1. But I haven't made the amide yet. I've only included the carbon of the carbonyl. In order to make it an amide, remember I need that bond to this nitrogen. So I need a single bond to that nitrogen. So right now I know I'm dealing with an amide. So technically I have butanamide. Whether or not this nitrogen has 2 hydrogen, 1 hydrogen, and a carbon, or 2 carbon, will depend on substituents that are present. Look to see what substituents you have. Your nitrogen should have 3 bonds. And so if you only have 1 substituent and 1 bond to the carbon of the carbonyl, then you have 1 hydrogen. If you have 2 substituents, as we see here, then you'll have 2 bonds to 2 different substituents. The bond to the carbonyl, you won't have any hydrogen. If we didn't have any substituents, we would only have that 1 bond to the carbonyl, meaning we would have 2 hydrogen. So looking at how many substituents will indicate how many hydrogen atoms that nitrogen should have. Just remember that the nitrogen will have 3 bonds. So looking at how many carbon atoms are bonded, subtract that from 3, and that tells you how many hydrogen. So in this case, we have N-ethyl. So ethyl was 2. So 1, 2. So 1 substituent with 2 carbon atoms. I had N-methyl. That. 1 substituent with 1 carbon. This nitrogen has 3 bonds, so it will not have any hydrogen. So now we have the completed structure of N-ethyl, N-methyl butanamide.